Okay, we're back on. Um, we did the energy part. We did yeah, okay. There's another thing, another concept that we need to go through, which is momentum. You know inertia.
I just heard of like law of inertia or something.
Yeah, Newton has three laws. Of course, the most this one, or
Yeah.
written as
I think it's
m
MA.
dx dt, or m dv dt. Okay, however you write it. This is, I think this is Newton's third law, right?
No, Newton's third law is opposite reaction.
Okay, what's the second law?
Second law, I have no
Is
idea.
this?
Yeah,
Okay.
pretty sure.
Okay. If we were wrong, you okay? If we were wrong, right, you need to look it up, okay? Because we're not sure about this. This is Newton's second law. Whatever. This is Newton's nth law, okay? Second law. Let's call it second law, okay? Could be wrong. Newton's first law is if an object, it doesn't have any force, it'll just keep on moving.
Yeah.
In its original direction. At the original velocity, it doesn't change.
Unless there's an unbalanced force.
Unless they're right, yeah, a balance force, right? If an object, right, you have a force here, you have the same force here. We call this, you can call this a balanced force, or you just say there's no force on it because they cancel out. You add them up. You add these forces up, right?
Eighth grade teaches you physical science, so
yeah.
I learned this.
Yeah. This is called
sigma.
Sigma, yeah. Okay. If you add all the forces together, if it's zero, you say there's no force on it, and this thing, this object, will keep moving, or still, if this not moving, is never gonna move. The thing that will keep moving is called a inertia. In other words, if you want to, another way to say it is, if you want to stop something that's moving, it takes work, takes whatever, to stop it, and that is you say this thing had inertia. It'll just keep on moving. However it is, but anyway, in physics that means if you don't put force on something, this thing just keep moving in its original direction. By the way, this is called Newton physics. Okay, it doesn't apply to things start moving very, very fast, or when things are very, very small. That's relativity and quantum mechanics. We're not dealing with that. We're just looking at the sort of what do you call it? Traditional views, traditional experience. Yeah.
Okay, sure.
Okay, now. So we introduce a concept called momentum. P, right? You know what P is?
Power, I don't know.
It's m multiplied by v. This is okay. Yeah, we're talking about energy, right? Somewhere we're talking about energy, right? We say okay. Okay, we say when a ball or a person that comes down from here to here,
yeah,
the energy conserved. The energy doesn't change. So all this change is the potential energy changed to kinetic energy. In other words, the height changed to speed. This height is converted into speed.
Yeah.
Yeah. That's a conservation of energy. It means energy doesn't disappear. Okay. We define the momentum this way because momentum is another momentum also conserve.
Yeah.
Okay. Let's do a situation. Okay. A ball comes in. Okay.
Yeah.
M V, right, comes in, hitting another ball here. M, this is velocity is 0.
Yeah.
Okay. Let's say when these things, this system happen, momentum always conserve.
Okay.
Energy not necessarily.
Mm-hmm.
Let's just say the energy also conserved in this case. Let's see what happened.
Okay.
Okay. We call this V sub 0, V1, this is M1, this is M2. They're all the same, by the way, okay? This is V2, 0, this 1 is 0, right?
Yeah.
This is equals to V, this is equal to 0, and then we want to know V1 and, right? We call it V1 after, right? We want to just call V11, right? V21, okay?
Yeah.
We want to know what V11 is and V21 is. So we write the conservation. The MV, you add this M1 V1 plus M2 V2, right? Right?
Yeah.
Before the move, this M1 V1 is V, right?
Mm-hmm.
Okay, so it's M1 V, right?
Yeah.
And then M2 V20 is 1. So that goes away.
Yeah.
M2 multiplied by 0, okay? That equals to M1 V11, right? Plus M2 V21, right? These we don't know,
Yeah.
right? You following?
Yeah.
Okay, so the M is the same, they'll cancel out. So V equals to V11 plus V21. Okay.
Uh-huh.
Now let's look at energy. Energy is M1 V1 square plus M2 V2 square, right?
Yeah.
This equals to before the collision is V10 square, right? M1 V10 square, right? That's this because this is not moving, right? That goes to this is 0. This is not moving.
Yeah.
No energy in it. And then it goes to half M1 V1 1 square plus half M1 V2 1 square. Okay, so this gets to V1. Oh, V10 equals to V.
Yeah.
Right. So this is V. Okay, let's start. V square equals to V11 square plus V21 square. Yeah. Okay. Now, okay. How do you want to solve this? How do we call this X? Call this Y.
Okay.
Yeah. Now, X plus Y equals to V X squared plus Y squared. So V squared. Solve. Well, it's two equations with two variables, right?
Aren't they just like 0, 0, and 0, and 1, 1, and 1?
Solve it. Do it the right way.
Wait.
No, you actually have to solve it, you know.
How do you expect me to solve it?
This is two, you know, you got two variables. Yeah, you have two variables. You have two equations. You can solve it, right?
Okay, sure. Yeah, that sort of didn't really help at all. Yeah.
Just keep
sure.
going. Where's the X? What's the X? You're already done. You're there.
Okay.
What about the 2? Right. Right. There you go. Yeah. Right. Yeah. Okay. You have two. You got 2 solutions, right?
Yeah.
And one of them, of course, X. We just said X. X is V11. This is V21. Y is V21, right? We know that when it comes in, X1 V11 equals to V and V21 equals to 0, right? When it goes out, V11 is 0, V21 is V. In other words, when it goes out, when this ball knock on this ball gonna stop. This ball is gonna go out of the V. You ever see those toys?
Yeah,
The
I know.
metal hit it, and
I tried this experiment already. Yeah.
and actually this problem I can put another ball here.
Yeah.
This
and
ball
it
hit
would
this ball,
still
this hit
work,
ball.
Yeah.
Yeah, it still work, right?
Yeah,
That's just what happened.
Yeah,
Okay.
I know. It's like the Newton's cradle thing.
Yeah. Now I'm gonna do another one. Okay. Instead of let's just get a new paper. How much time?
11 or
Okay.
12.
Yeah, we have plenty of time. M1 V, right, comes in. Right, this is M2. Right.
Yeah.
Once it collides, right, it doesn't get stuck together.
That's gonna get stuck together?
Yeah.
Okay.
So in other words, it comes in as M1V, right?
Yeah.
When it goes out, it's both of them gonna go out at a certain velocity,
Okay.
right? This is one is easy. This is the energy not gonna conserve. Okay, this thing burns energy. In other words, for this case, like those metal balls,
Yeah.
they bounce. There's a shape change when you hit it, but then it's elastic. They'll bounce back. There's no energy lost in that. Whatever energy you put into the ball, you get it back. Now this one, when they stuck together, there got to be some shape change or something permanently. That will cause energy. Okay, but anyway, this velocity equals to m1, m2 v. See that?
Yeah.
This is how fast, when they stuck together, when they go out, this is how fast it's gonna go.
Okay.
Yeah. Any questions?
Not really.
Okay. Any questions? I'm open for questions. This is only 13 minutes.
Can I eat? I'm hungry.
Okay. Since you have no questions, let me give you another problem. Okay. Let's say you put out a rocket. Okay. You know the difference between airplanes and rocket?
Yeah.
What's the difference?
Rocket's supposed to shoot like straight out of space and past the atmosphere, and then airplane just glides in the air in a way.
No. Okay, whatever. What's the physics difference? Is there any physics in physics perspective, right? Is there a difference between how the rocket moves and how airplane moves? They all blow things on the tail, right?
Yeah.
What's the difference?
Like, the rocket shoots like almost straight up or straight up.
No. Rocket shoots flat too. Horizontal also. I think those cruise missiles probably is the airplane. But anyway, you want me to just tell you? Rocket has fuels in it, right? And those fuels, they blow those fuels out of rocket.
Okay.
So, rocket can move anywhere. Rocket will just blow, and then you have a rocket that's M, right? Right. that moves at the velocity v, right?
Yeah.
Let's just say the fuel that blow out is ignorable. Probably it's not. Actually, the fuel is, I think, 90% of the weight of the rocket.
Yeah.
It doesn't really matter, actually. So you blow out fuels, right? The fuel blows out, let's say M fuel, right? Is at a horribly high speed, right? This is, let's say this is the big velocity, right?
Yeah.
And then this is M minus M fuel, right?
Yeah.
This is the V at the end, right? This is the how fast this rocket moves, right? And now it ejects fuel at a very, very high speed, right?
Yeah.
And this is the end velocity, right? Let's see what it is. Yeah, you move this over and divide this over, right? Vt equals to m v0 minus mf. Actually, no. They blow this to the front or to the back. They always blow it to the back, right?
Yeah.
So this is minus, actually, right? So you want to add this. Right?
Yeah.
This is very, very big number. You blow this thing very, very fast. Okay? Of course, you blow this thing as fast as possible. Yeah? Already. You see this is the final velocity. You want to increase the final velocity. I mean, whatever you're going already. You're not going to make it faster, right?
Yeah.
The only way to make this sucker go faster is to put out more fuels.
Yeah.
It's the weight of the fuel that's doing this. You understand this? It's the weight of the fuel that they put into rocket that's pushing. That does the pushing. Okay? Airplane engine, however, is a different thing. Airplane engine, they have air coming in, right? Air coming in.
Yeah.
Then there's explosion in here with gasoline. Okay? And then the air get blown out. So this is the velocity in, this is velocity out.
Yeah.
The velocity in is a lot less than velocity out because there's explosion in here. Also, because before this air get blown out, right, it push a turbine that creates electricity. That's when when you're in an airplane, you can watch TVs or whatever, right? That's the air blowing out that creates electricity. Also, this thing needs to be turning, and the air blowing out creates this turning. Right? So there's the problem of how to start this business, how to start this running, and then you need to start the engine. But anyway, let's not worry about all those things. The things we need to worry about is the velocity air coming in and the velocity air going out is different.
Yeah.
So in this case, let's say the airplane velocity is m, right? So the mv sub 0, this is where it flies, right? Equals to basically just this air, right? M air, right?
Yeah.
That goes out at the higher speed, but it certainly is minus, right? Then plus this is air. This is airplane, and the velocity at the end. So this comes down to more or less the same thing. This would be t equals to m v0 plus m air v divided by m. Yeah?
Yeah.
This air is not contained in the airplane. It's air that it takes in. The engine, you see those engine on the airplane, right? You know what I'm talking about, right? When you see the engine on the airplane, it's like when you look at this, the engine on the airplane, you see blade in here, right?
Yeah.
Blade maybe turning, right?
Yeah.
That's air going, suck air going in. You know the birds going into. Anyway,
Okay.
you know what I'm talking about, right?
Yeah.
So, in other words, for the airplane, does the airplane fly when there's no air?
No.
Yeah, airplane cannot fly high because on our Earth, right? This is the Earth, right? The very dense air around here. When it go out, there's no more air.
Yeah.
So when you want to shoot something out to the outer space, right, you have to use a rocket.
Yeah.
You cannot use airplane. Yeah, this scheme doesn't work. I think they're building the airplane that they use this those airplane things to fly as high as possible, then turn on rocket to go out outer space, because this saves fuel.
Yeah.
And rocket, you have to burn the amount of rocket out, the material, the you carry, the fuel. It normally is liquid hydrogen or something else. Liquid hydrogen you mix up with the oxygen, then it becomes water, right?
Yeah.
It gives out energy,
Yeah.
and that's the energy that they put out. I don't know what they use actually these days, but did you ever do a thing that hydrogen and oxygen get mixed up?
No.
Okay, it explodes, create a big noise.
Yeah, there's a reason why I never done it.
No. It's not destructive. When you put a little bit in, so maybe high school they always do that. It's just to scare you off. It's fun and no danger. Yeah. Anyway, you ever seen liquid nitrogen?
Okay. Yeah, I know.
You know? Okay.
Yeah, I can spray it on people.
Yeah,
but it
you
won't
can
freeze
put your
them
hand. Yeah, you
because-
can put your hand in the liquid nitrogen. But you gotta. You don't do it, okay? Because if you don't handle, you know those things, it really freeze your hand into a solid. Okay, that is the problem of rocket. You have to carry so much fuel, so that creates so much velocity of the rocket, so the rocket will get out of the Earth's orbit.
Yeah.
Okay, we're not gonna put this into number. Let's see what time it is. 21. Let's do another.
Yeah.
Okay. Yeah. Okay.
I'm tired.
Okay. We'll see you next time.